that. All right, take it away, Kyle.
Cool, thanks for that. So what's up, community college program students? We're a part of AVELA, and we're gonna be, with y'all for the next hour. So a little bit about AVELA first. We're a student org at the University of Washington that's really big on representation. That means the race, ethnicity, or community of underrepresented minority students that we end up going out and supporting, like those that are involved in MESA or Upward Bound or any other type of organization like that. We reach out to, community college and high school, middle school, Black student unions, Society Hispanic Professional Engineers, groups like that. Another big pillar of our organization is Ubuntu, which means a humanity towards others. So we're really big on empowering students to go and, reach their potential through different STEM projects. And then the last one is adaptation, which y'all will see here is we're going to be asking all of y'all what types of projects you want to do. We try to avoid just kind of coming in with one, rigid program. And so what we're trying to do is figure out what's interesting y'all so we can kind of, tailor it towards your interests. So here's a quick little rundown of what we're going to be doing. Introduction to all the panelists that will be speaking. Then we're going to talk about some of the research and work we've done before. The Q&A is so we're going to leave time for y'all to ask questions and kind of interact in between. We're going to explain 4 different workshop ideas that we have. And then at the end, we thought it'd be fun to play a little Kahoot for a $25 Amazon gift card prize. And I'll just need the email of whoever wins if we get to that. So without further ado, I'll hand it off to my good friend, Kiana.
Everyone, so my name's Kiana and I use she, her pronouns, and I'm a senior at UW majoring in biology and I'm minoring in education. And my reason for kind of doing both STEM and like humanities majors is because I personally love science, but I can't see myself just sitting in a room only focusing on science. And so I decided to take a more humanities approach to like pursuing a career. I want to go into medicine. So I figured like if I have like an education background, it'll be easier for me to close the gap between like patients and doctors, just because there is such a huge gap when communicating issues around health. A lot of people like just are uneducated around these topics. And sometimes doctors have like this, like hierarchy or it's like, well, I know everything. So I figured education would be a nice kind of well-rounded thing to like my love for like science. I'm also the president of the Black Student Union at my school. And I also love dogs. As you can see in the top right corner, those are my 2 dogs. And I have 6 plants. They're right there. And then I love sunsets, and that picture is taken in my room. So yeah.
Oh, forgot I was next. All right, well, hi everyone. My name is Morel. I'm a senior studying computer engineering, University of Washington. Very passionate about machine learning, artificial intelligence. I have a lot of small projects that I like to do in those fields. And one of the most recent experiences I've had in that field was my software engineering internship at Facebook this summer, where we used artificial intelligence to attempt to solve privacy issues with messaging. And also I work as a teaching assistant at UW. I teach a class, I'm a teaching assistant for a class called the Hardware Software Interface. And some of my passions involve, non-engineering passions involve eating seafood. I love trying out new seafood places. Pokemon is one of my favorite games, and also just going out, hiking, rock climbing, anything physically, where I can be physically active, I'm down for it.
Then Charles, you up?
Yeah, hi everyone. I'm Charles, PhD student at the Information School. Just new in Seattle. I just came 2 months ago, and I'm excited to be part of this group that seeks to help people. I'm from Ghana, and I also do a lot of community work. So the pictures you see, you can see me in action. I'm a former student of University of Ghana. I have my master's in IT. I've never been in India, but I was attending in Ghana. I mean, it was, let me say, an open university. We had our classes and our grades were being, awarded by the Sikkim Manipal University. I have been lucky to get some awards. I was the best graduating overall, best graduating student. So I had the opportunity to speak to the graduating class. And if I have a happy day, I love to eat fufu and palm nut soup. So those are just samples of that in your screen. I took those pictures from Google, so maybe when you come around and I cook that, maybe you love it. So I'll have time to talk about what I've been doing, and then my research work very later. So thank you very much. I give it up.
I'm trying to hire you chef for me. But so what's up, y'all? I'm Kyle Johnson. I'm a PhD student in computer science at the University of Washington. I'm actually a transfer student as well. So out of high school, I didn't have the money, sat down with my parents. We looked at the checkbook. It didn't add up. So I ended up taking a year to work. And then I took the first offer I had for a full ride, which was actually at an out-of-state school. And while I was there, I was not a big fan, which is why I'm going to leave this name of the school MIA from this talk. But I was always wanting to come back to the University of Washington. That was always like a dream, one of the top schools in the country. And so I actually ended up working there for a year, getting my grades up, applying to scholarships, and then transferring back to UW. And then once I was here, I really took advantage of a lot of the resources, which is why I was excited to come. Faculty, professors, scholarship opportunities, things like that. And so I co-founded the Black Graduate Student Association in my grad school here. And in my undergrad, while I was here, I actually founded this org that we're all here for now, which is AVELA. The idea being like outreaching to students who maybe didn't have as much access or guidance. I know that it took me 2 years after graduating high school to get to UW. And I'm thinking, okay, from my experiences, I think I could help others who might be in my shoes make their way over to UW a little faster, if that's their goal. And then so I'm also kind of a little bit, I enjoy cooking up, good foods like jambalaya and other types of gumbo, pasta types of stuff. And then I also love hooping, like high key, one of my passions. So on the weekends, you can always see me crossing over little kids out on any type of court in Seattle. But anyone got any general questions? This is a time for open audience. About us personally, hobbies, things like that. We'll have more chances throughout the talk to speak to other things if you are feeling shy right now. And you can feel free to just unmute yourself.
Sign up. Where's the sign up?
Kyle, I actually have a question for you. You said you were a transfer student. Where did you transfer in from?
Yeah, I transferred in from out-of-state four-year college. So it not quite the community college experience like in-state from Clark or anything like that, but I'm originally went to high school in Vancouver. So I'm very familiar with Clark. The reason I wanted to go the four-year route instead of going to Clark was because, again, I was like trying to get those resources that are like very abundant at large public institutions, meaning, like financial aid support, the professors who always have like research opportunities, a lot of tools that are available within certain lab spaces and things like that. And then let me just real quick here.
Kyle, we actually have a question in the chat as well. The question is, what are the primary goals of AVELA?
Cool. Yeah, I see the question now from Connor. Liban, I'm gonna let you introduce yourself because you got accidentally skipped. And I'm gonna let you tackle the what are the primary goals of AVELA question.
Yeah, no problem. Good afternoon, everybody. My name is Liban Hussein. I think I was saving the best for last, no pun intended. I am a PhD student at the University of Washington. I'm studying electrical and computer engineering. That's actually what I did my bachelor's and my undergraduate degree. And so I also studied electrical and computer engineering. And like many of you, I actually went to community college before coming to UW. So I was a Running Start student. I did a couple of years. I completed my prerequisites. I stayed an extra year and finished up some classes, and then I transferred directly into the department. So if there are questions in that regard, I can definitely answer. I am Somali American. I was born in Columbus, Ohio, but my parents hail from East Africa. At some point in my life before engineering, I really enjoyed long distance running. Post-engineering, things have changed a little bit, but I like to get out every once in a while. And like many of you, I'm also a member of AVELA. To tackle the question, I think that was brought up with regards to what are the primary goals of AVELA. What we're really trying to do as an organization is reach out to students that come from similar backgrounds to ourselves, that may not have had the same opportunities that we currently have, and providing outreach and services to basically help engage students from underrepresented groups in basically getting the leg up when it comes to STEM. A lot of us know that when it comes to transferring to universities, attending universities, completing prerequisites and doing all of these things, oftentimes we might feel that given our background or given the circumstances that there might have been when we were going to school, like from elementary up till high school, there may not have really been outreach programs, or there may not have been good introductions to STEM. And what we're really trying to do is we're trying to facilitate that. We're trying to help people understand and give them the experiences that will help give them the leg up so that when they transfer to different institutions, they'll find that that they have the advantage of knowing that they come with a background, they come with a resume that has projects and different experiences, and AVELA is there to help facilitate that.
Killed it. So then I think that was good, unless anyone else had questions for us right now. Otherwise, we might just keep it pushing to our project experiences. Cool. Yeah, of course, Con. So we'll kick it back over to Kiana, and hopefully, Liban, you don't get skipped this time.
Okay, so I am not an engineer at all. I'm actually a research scientist, and I work in a lab in South Lake Union. It's called the Murray Lab, and our lab studies coronary heart disease. So like we're trying to help people who have suffered from heart attacks and things of that nature. And so our lab, what we do is we take stem cells, which are cells that can become any type of cell in the body. Thank you. And we turn them into heart cells in a petri dish. Well, not a petri dish, but a dish in our lab. And so in doing that, we hope to take the cells that we derive and then put them into the hearts of individuals who have suffered from heart attacks. That's like the overarching goal. Currently, our lab, Charles Murray, he was one of the first, or was the first, like research scientist to be able to turn these stem cells into heart cells and then put them into animal models. And that can restore some heart function after inducing a heart attack on the animal models, which is insane. And he has a TED Talk that he talks about it. And I'm gonna put it in the chat because he is amazing to me. So let me copy it here. But yeah, Chuck Murray, my PI, he's founded like the Center for Cardiovascular Biology, Institute for Stem Cell and Regenerative Medicine here at UW. And so very big name, but I work in his lab. And so I'm trying to figure out a way to, again, derive heart cells and then be able to put them into humans so that when you have a heart attack, like your heart functions properly. And the focus of my project, I study like DNA methylation. So basically like DNA, DNA to RNA to proteins, and then you get to see like protein expression, like skin color pigment and things like that is because of proteins. And my goal is to figure out a way to like see how this modification, which you can kind of see like on the screen, DNA methylation is where this like thing gets attached to DNA at the promoter. And if something is methylated, it will actually turn off a gene, so it won't be expressed. So for example, like if I methylate the gene for skin pigment, like I wouldn't have pigment. So I'm trying to find a way to turn off methylation in specific genes in heart cells so that I can make more mature heart cells. And so that when you put them into the animals, the heart function is a lot better and more adult-like. So yeah, that's my research project. And you can see the cells, but yeah.
Thanks. Shout out to Morel.
All right. Well, I'm not a researcher, but well, so first I can start talking about so what I was doing and what I will be doing next year at Meta or Facebook. So we're working on improving the messaging infrastructure within all the apps that Facebook can manage. So because Facebook manages like Instagram, WhatsApp, Messenger, and all that. And one thing they've been trying to do recently is allow cross communication between those apps. So if you go on your Instagram profile now, you can now send a message through to a Facebook account or things like that. So we work on trying to make that happen, and also make sure that we're still compliant regarding privacy issues and all that stuff. I'm also part of the engineering and team at the Robotic Association of Robotics at UW. It's a club where basically we build a set of robots, each having a specific role, and our goal is to join this competition where we basically fight against other robots, and then there are specific rules as to how we get points and everything. And yeah, so every year we try to improve on our robots and then just compete. And as far as personal projects that I've done, so one of the most recent ones that I've done was to build a very minimalistic version of a computer on a breadboard. So breadboards are the things that we use in electrical engineering or physics labs just to build small circuits for experiments. And basically what I did was building a computer, very small. It had only like 8 bits of memory, so it could do everything you can as long as it's between 0 and 256, basically. So any could do any computation within that range, but it really helped me understand like how all the parts in the computer all go together. And also another thing that I worked on, so I sometimes read a lot of research papers, and one of the most interesting ones that I read recently was the AlphaGo, which is one of Google's attempt of using machine learning or AI to build a model that can beat the champion, the Go champion, which is Go is a very complicated problem to solve using computers. So it was a huge milestone. So I tried implementing their algorithm, but on a simpler game, because I didn't have the capacity to train a model on for Go. But so I used it in a game called Connect 4. Hopefully some of you are familiar with that. And I was able to beat the game like 7 times out of 10. So it wasn't that smart, but sometimes it would surprise me. But yeah.
That's cool. That's related to a project we're going to talk about later, right?
Yep. Yep, exactly.
So, okay, Liban.
Yes, so like many of you know, I am an outreach mentor and teacher through AVELA. I've done a couple of projects primarily with Highline College, but also some panels and talks like that. My past experience, so I was an intern after my junior year of college or university, I suppose, and I worked for Texas Instruments. I was not working on calculators as many would presume, but I was working on demos for autonomous vehicles. And it was really nice that walking in with very little experience coming in besides a lot of the theory that's covered in school, being able to create a demo for some leading automotive customers like NIO, Tesla, and Mobileye was something that really, I think was a really fruitful experience. So I got a lot out of that. I really enjoyed it. And I didn't get a free calculator, but I definitely got a lot of good experiences working there. Kind of fast forwarding in the future, actually this past summer, I was awarded a fellowship that's known as the GEM Fellowship. Kyle as well also has that fellowship. And that kind of comes with the stipulation that they help funding for graduate school, but they also provide you with an internship. So that was really nice. I got to work on integrated circuits, which are small chips, but they're used for cryogenic application, which is a little bit different than what I was accustomed to. So you can imagine you have some chips in your computer, or you have chips in your phone that basically like do all of the memory and computation. But what happens when you need to use those for super cold temperatures? Things like cryo experiments and things that are like you're trying to like work with like super high speed physics, right? That's something that I had worked on, and that was also a really fun experience. Despite working remotely, I learned lots and met lots of people. My real interest, though, besides flexing on Tesla and working at national labs in the garage, what I really enjoy doing is working on medical circuits. Where I come from, there's a strong like lack of access to medical technologies, and I find that oftentimes with the right mindset, you can take a lot of these things that might be in hospitals, things like pulse oximeters, things like heart rate monitor circuits, even things like imaging devices, and you can find like really cheap and efficient ways to implement them. And that's what I'm really passionate about, is developing medical circuits for a bunch of different applications. One thing that I'm looking towards the future is replacing CT scans and MRI scans with like kind of wearable like headset devices that are much more efficient, don't give you radiation, and can be used in third world settings like places that I come from. And that's something that I'm really passionate about. And you'd be surprised, like there's a lot of this stuff that's going on with medical circuits in terms of being implantable. We've all seen what Elon is doing, but it's actually a really old technology. In fact, the first implantable device was implemented in 1965. So I won't say it's a super mature field, but it's something that's there. And it's something that I'm interested in working both in terms of implementing things to help with like neurological disorders, but also doing things like non-invasively to help treat different things, and to help detect things like Alzheimer's. And I think the culmination of all the experiences has certainly helped kind of push me in that direction. And I'm looking forward to working with other people and learning more and being able to give my 2 cents. So just a couple pictures there. That one there's a picture of me. The one next to it on the right is my senior design project, which is an end-tidal CO2 monitor. So, when somebody gets put in an ambulance, they have to put like a tube there, but that tube can oftentimes get like yanked out. So we're working on finding a wireless solution for that. The complete opposite on the left is a solution that's full of wires. So that's what I was working on at Texas Instruments. And then just a diagram of different applications for medical circuits.
Hopefully our labs get to partner one day, Liban.
Soon.
Yes, before I came to UW, I was working as a lecturer at University of Regent Chopin College of Applied Sciences in Ghana. I lectured in IT courses like web development, Java, and Android development. My work is an intersection between library work and IT. So you see a picture of me in the library and another working. I'm interested in looking at how misinformation affects those who cannot read and write. And I think it's a very important aspect that affects most developing democracies, because we have a number of people who cannot read in any language, and our politicians sometimes have this attitude of using them as a way of getting into power and making things that make it difficult, especially with this COVID-19. There's so much misinformation. So my interest is looking at how to understand how the people who cannot read in any language but have mobile phones, how do they access their information? How do they know that this is misinformation, and how to go about that? So I'm a research assistant and a research fellow at TASHA, that's Technology and Social Change Group. That's basically the work we do, looking at underserved communities, digital literacy, and how IT can help them to be empowered. I mean, because that's where the world is moving into. So over the years, as a researcher, I have done a number of papers. We looked at a project in Ghana that was looking at how IT could be connected throughout the country. And so for over 10 years, we're looking at how that project has been able to help the country. That's library connectivity project. So a group of us wanted to evaluate the project and know how it works, and it accumulated into a research paper. We have another project under review, which is looking at how academic librarians can help in mitigating the issue of fake news, and make sure that at least people are able to control their emotions. We cannot prevent misinformation. It's out there, and you cannot force people to accept what is true and what is false. You can only help them to be able to control their emotions, because nobody can tell which one is true and which one is false. So it's looking at, okay, when you get the information, what should you do to be able to control your emotions so that everybody respects whatever the other is thinking or, looking at. So that's what I have done in the past and what I'm currently doing. My supervisors are Katie Davis, the program chair at the information school, and Jason Young. He's also very good in this area that I'm researching. He has done a lot of work in Africa and Ghana. Yeah, take it.
Thanks, Charles. That's dope work. I swear read one of your papers because I've been reading up on some of the issues over there with misinformation in ethics class. But me personally, first and foremost, I actually am a researcher, so this is a little backwards. I like to research on robotics, specifically like insect scale robots that are really low energy and even batteryless at times, using things like solar power or Wi-Fi to operate. And so they achieve that by having really efficient structural systems, as well as really efficient electronics. And that's why I mentioned that joke of working with Lee Ban later, because his lab is working on trying to make, really efficient, devices, like electronic devices and circuits, so that these types of robots can actually run without a battery, but maybe just, from the Wi-Fi service that's just around you normally. And so these are a couple examples of things that I've made in my lab so far. Using this bottom left one here is a leaf out origami. The bottom right is another example of what that leaf out origami looks like. And this top right one does a similar thing. And then I'm also a machine learning software engineer as a private contractor at NASA. So Liban also mentioned that GEM fellowship earlier. And so what the fellowship does, on top of just giving you money, they also connect you with like an industry partner. And that's another big thing when you're looking for applying to, if you plan on going to grad school or even just at the university level. Looking for scholarships that aren't just money is another really good way to get connected with industry partners. So everyone's like, right, trying to get a job one day, start a company, do these different types of things. And sometimes like scholarships and fellowships will specifically set you up with different companies. And that was how I got involved at NASA, and I highly recommend that for others. And so that's why I've got a couple images of machine learning over here. Yeah, and I guess that'll wrap it up for me though. Any questions about the projects that anyone has worked on? I know we talked about a lot of different projects. And again, no need to be shy.
I have a question for you, Kyle.
Yeah, what's up?
What is your first 2 years attending college? What are smaller projects that you've done that helped you learn or get your foot into programming?
That is a perfect question because it ties into why we're here. So the projects that we're going to recommend to y'all later, those are the types of projects that I had done when I got into my first and second year. I got into, like a research lab and doing things through outreach. So I learned about like microcontrollers, which is like the brain behind, a computer. And I learned about how to like wire things up and code things, high key, not from a class. The class was cool. It gets the foundation of knowledge. All of that is there. It didn't really stick for me until I was actually going out and doing it for something. So when I was actually having to like make these circuits to go and teach to a class, or when I was having to, you know, learn how to do a certain type of coding in order to go and teach someone else, that was when I was really motivated. And that was kind of how I got my experience. Every single job interview I've actually gone and done. So I've also worked at like Whirlpool, which is like a services company, and NASA. They always ask this question of, oh, describe a project that you're passionate about. And every single time I've described a project that I worked on through AVELA. And so to me, that's just something that's always been super easy, super comfortable, and something that I've had a lot of control over in the design and fabrication process, because it's not someone else telling me to work on one part. It's not someone else telling me, hey, this is exactly how it needs to be done. It's a space where we kind of get to like explore our own interests, design it the way that we want to, because it makes sense to us. And that's always been what's easiest to talk about when I'm in those interviews. And so those were the projects I was doing in my first few years that kind of built the foundation to the things I know now.
Nice. Thank you.
For sure. Anyone else got questions? Let's see here. Connor said, how might you find scholarships that aren't just money? If Morel, Kiana, Liban, Charles, one of y'all wants to tackle that.
Yeah, I take it that you might be referring to like a scholarship or fellowship that might come with something like GEM, for example, where you might have like a summer internship or something like that. So I had found out, I'm pretty sure I found out GEM on accident. I was at a national conference, and then they had been there, but I had not heard of them prior to that. So I think that's how I had been aware of GEM. And then from there, I think like when there's a concern for funding and it's like, all right, I'm planning on going to graduate school. What are some different ways? There's a few different routes that you can go in terms of doing that. So sometimes a company will pay for it. So you could be getting added experience from that if you're going for a master's, for example, and working through that. A GEM fellowship and things like the ones that are provided by the Department of Defense and things like that will typically come with some stipulation. We'll give you an internship, we'll give you a full-time offer. So I would say that there is a list of them. I think that it's a little, that pool is a little bit smaller when it comes to scholarships and fellowships that aren't just money, but they certainly exist. And I think like going to national conventions, asking people around, and kind of looking into just different fellowships overall, ways to fund graduate education, you'll find that there are a few different ways that will typically come with summer internships, even full-time experiences.
And just to add to that, I want to echo what Janae put in the chat, which is thinking about what else you want to gain, like a mentor, because a lot of the times the mentor is just the middle ground. It's the first step towards getting that internship. I mentioned that I had always talked about all these AVELA projects whenever I've applied for internships. I'll also say that I don't think I've ever applied for an internship with someone I didn't know. And having that foot in the door has always been through having a mentor who's very involved in different organizations and is very well connected, reaching out for me. So having those mentors, it might seem like, well, what am I getting out of that? Like networking is very huge. And you got to make sure that you have, your panel of people that got your back that can go and vouch for you when you end up wanting to go and get a scholarship or need some money or trying to find a job. And so I think that's kind of what you need to be looking for, on top of what Liban said, which is like, who is going to have the internships tied in with their scholarships? It's going to be the company internships. And then I'm going to skip around, so I'm not talking too much. Is computer science an effective pathway for researching robotics, including their hardware circuits and materials focused aspects? I'm going to let Morel or Charles give their insight on that.
Okay, I can answer that. I would say computer science is definitely a great way to get into robotics. Me personally, I'm majoring in computer engineering, which is a mix of computer science and also the hardware part. So I'm a little biased when I say that. I feel like that's one of the closest majors to, I don't know, to getting a master's in robotics, because you kind of have the fundamentals on both sides, which is the hardware and the software. But I feel like robotics in general just involves so many majors that I've seen mechanical engineers get into robotics, after they graduate. I just think depending on which part of which area of engineering you come from, you might have to learn other things, but it's not impossible. But computer science is definitely the most common, at least from what I've seen.
Anything to add, Charles?
Well, not much, but just to say that, like what Morel said, it's a broad field, so it's not just one. So
Cool. Yeah, and then I'm gonna answer. It was
probably just to add to the first one, I think apart from the ones that give money, like you mentioned, if whatever you want to do, you need to get somebody that is working in that field. And that is what has actually brought me here, because I looked at somebody's work that was related to what I was doing. I started a conversation with the professor and like told him about my interest in getting a PhD to go back to Ghana and be a professor. So that's how come I got the fellowship and the scholarship to come here. So it's not all about money. I mean, sometimes you need somebody to understand the work that you are doing and to push for you.
and then they'll find the money for you, right? So to answer the question, Kyle, what got your interest in working on insect-sized robots? I was typing this out in the chat. I think it'll just be faster to say. I like the idea of swarms. I remember I was so fascinated watching NASA's space rovers go out and explore like the moon. And now, right, we have a drone that's on Mars. And one of the things that always got to me is that they talked about, like an icicle, fried one of the circuit components on the board, and now the thing's completely useless. And so what was interesting to me is the idea of swarms, where you can have tons of devices where if some of them break, even 50% of them break, you still have a way to see and collect data at that site that you're at. And the only way I think that's really feasible to do that is when you scale down these devices and have something that's smaller so that they're easier to move, right? Everything that we take off the ground and put on Mars, we got to get through our atmosphere. It's got to fit within the rocket. And so I think there's a lot of size limitations that come with that. And that's kind of where my interest in making these small scale robots comes from, because I think there's a lot of applications, not just throughout space, but also having, robots that are working in teams or in unison to go throughout a house maybe, and take images and 3D map the house without, having to take 2 hours that a drone would have to do to go into each individual room and map it separately. Like having devices can really like speed up the process of checking for gas leaks. Instead of having one device that has to check maybe the whole pipe or the whole building for where the gas leak is, send out a swarm of devices and it can find that gas leak a lot faster. And yeah, to answer Russell's question as well, I did my undergrad in electrical engineering, and a lot of classes that are offered there, you can are computer science related. And so that was how I ended up switching over to computer science while I was still learning about the hardware and circuitry. And yeah, Charles is dead on. Software makes machines work. So we'll keep it going. We'll talk about our projects right now, but feel free, if we got time at the end, we can, continue with more questions then. So I'm gonna let Lee Ban talk about this first one.
Yeah, so the first project that we'll be talking about is the ARHM, so the analog heart rate monitor circuit. The first time we worked on this circuit was actually this past summer, where we were working with Highline College. So you guys are familiar, like I was mentioning, like pulse oxes. You'll go to a hospital, for example, and then you'll put your hand kind of inside of this medical device that will basically check your oxygen saturation, but it'll also check your pulse. You can imagine that in a third world setting, it wouldn't be very feasible to put a very thousands of dollar piece of equipment in a place that may not have access to medical devices. So we said, wouldn't it be nice if we could make a very cheap version of this, where you can basically build it for less than $10 while still achieving the same functionality. That's something that I actually did with Highline College. By the end of the summer, the students were able to build it. And one of the benefits, or several benefits that were included in that, is that they were able to kind of take the design and then understand, all right, how can I simulate a circuit, or how can I test to see what different softwares are there? And they actually ended up building it and testing those assumptions. And then another benefit with that is that, like we were mentioning, oftentimes people might not have a lot of experiences before before transferring to the university, the analog heart rate monitor circuit was an example of one project that we did as AVELA to help students gain that experience. And I think it's a pretty dope project because it worked. So we're really happy with that as well. And it costs less than $10. I mean, that's really
That was
impressive.
what I was about to ask you.
It's a very cheap circuit, and it's still achieved the same functionality. You can see actually that's Kyle's hand right there. And then by placing your hand on top of this IR sensor, it basically pulses some light into your fingertip, goes through basically the blood, and then it'll basically take that reflected signal into a different piece of circuitry. And then from there, there's a little bit of stuff going on there. Stay tuned for part 2. And then from there, you can the LED basically flashes with your heartbeat, which I think is very impressive.
$10. Yeah, that's cheap. And then you want to explain this one too, Liban?
Yeah. So something else that we also did fairly recently with Kent Ridge High School, and among other schools, actually, the one that I did most recently with the 3D printing stuff that we've done with other schools is basically like, doing 3D printing workshops, but keeping in mind like sustainability and, developing printables or printouts that are 3D printed, but are also environmentally, conscious, green friendly and things like that. So, we can see there's just a couple of examples here. You'd be surprised to know that there's like over, I think, 15 trillion, tons of trash in our oceans. So kind of keeping this thing in mind is not just something that we're keeping in mind, it's something that people in the industry are also keeping in mind in terms of making more sustainable solutions when it comes to like developing these different things. Here's another example actually of a dissolvable 3D printed mouse that was done in conjunction with Microsoft Research. So this kind of goes beyond the scope of just outreach within the local community in terms of like school. There's also projects that we do that are in conjunction with industrial partners, things like Microsoft Research, where you can develop these different devices, whether electronically or 3D printed, but also keeping in mind that we have a significant carbon footprint on this planet. We have different ways of taking care of that and developing devices to make sure that we're conscious of that influence.
Yeah, and so just to emphasize these projects too that we're talking about here are example projects that we're going to be asking you if you're interested in pursuing. So that analog heart rate monitor, let me go here. This is a project like Liban mentioned that we've done with Highline that we could also do with your community college. And to the benefit of the community college, the parts are very cheap. And so then the 3D printing is also something that we could do with your community college, setting up designs. There's free online softwares. And another project that Morel is going to talk about here is learning about Python coding.
Yeah, so this is a very interesting and useful project for people that are not very familiar with coding, and for people like me that are very visual learners, because when I learned programming in classes, it was all like fundamentals of programming and it was really hard to follow. And when I started learning on my own, I would Google things like how to make video games with Python or how to do this with Python. So I think this is a very fun project for that. So the first thing that we're going to do using Python to code what we call fractals, which are these like complex patterns that you basically create by repeating a simple process over and over. So if you go on Google now and just look up fractals, you'll see a lot of beautiful pictures you can do just based off of like one geometric shape and just repeating that shape. So it involves a little bit of math, not that much, so don't be scared about that, but it also helps you learn a lot, about some programming concepts like recursion or other things. So that's one of them. Now on the other side, so this is there's a ping pong game to kind of tie it to what I did personally with Connect 4. So here, basically what we're building is a ping pong video game where on the left side, this is the actual player. So you will be moving up and down. And on the right side, that's an AI playing. So not only are you going to learn how to actually implement or build the video game, but also that you're going to learn some algorithms to help the AI learn how to play the game by itself. And to do that, we'll be using a platform called Google Colab, which is a very interactive platform for coding, where you can have little sections, little mini projects, and then complete them. So it's very easy to follow instead of having, just huge projects, whereas, you don't really know what's happening. So, so this is also very, it's going to be very useful to be able to keep track of everything. Yeah.
Thanks, Morel. Yeah, I just wanted to echo to where he's talking about the platform, and all of the coding with this project is at an entry level. So you don't have to come in with any prior experience. Like, we are teaching this for folks who are just getting into Python coding.
Exactly.
So then the last project is actually one that NASA is offering. So Washington NASA Space Grant Consortium has a student challenge that they have reached out to me about and said, do you have any community colleges that are interested? They have about $2,000 in funding for community colleges to buy parts like Arduinos or Raspberry Pis. And the overall goal of this challenge is to build some kind of, robotic rover that maybe has wheels or crawls, something like that, and to code it so that it can navigate through what they call a model lunar lava tube. They think that when we're on other planets, the fastest way, the best way to travel around is going to be through these lava tubes, because you don't have to deal with a lot of other material, environmental things happening on the surface of the planet. And so if you go through these lava tubes, you can actually, maybe get some good images and stay safe when it comes to a lot of the things that happen at night on other planets, like crazy storms and extreme colds. So they have this, model lunar lava tube that you can make. And the whole idea here is just kind of like using Arduino to make some kind of device. And then, through the NASA lens. So I'm just looking at the time. Do we have any quick questions about the projects, just to make sure everyone understands them? If not, we would like y'all to help us decide which project to teach. So there's a QR code here. Someone is also going to be my friend and drop a link to the Google form so that you can fill it out. It's just like a simple one question, rank the projects, the analog heart rate monitor, the 3D printing, the Python coding, and the Arduino project. Which one you're most interested in to the one that you're least interested in. Thanks, Kiana. And for the NASA rover project, the deadline, I believe, is in June. It's at the end of the year. We would either work with the community colleges to do that specific NASA rover project or another Arduino alternative. So if you're interested in the Arduino class, that's what you would vote for that. And then maybe you can make a note about like being really interested in the NASA project, because that would be one potential application or partner we use. And for none of the projects, just to answer, Vishal had a question, is prior experience needed for, they mentioned one project. You don't need experience for any of these. So we're going to teach at a baseline for Arduino, for coding, for modeling, for circuits. Everything is going to be entry level, and we're going to build up to these, what seem like right now intimidating concepts. But by the end, y'all will be followed along, and it'll be lots of fun. And sorry, Sarah. Yeah, we also have it. So you have to rank only one project per. So no putting them all as number one. The NASA project, that's a good question. I don't know if it ever has. To my knowledge right now, that is not like on the table. However, we had just talked about, right, doing these kind of industry sponsored competitions is a great way to like kind of get your work out there and maybe impress someone. So that is not like a part of the program at all, but I don't know who it is from NASA that we would work with specifically. So sorry, Rasul, but I don't know. Just gonna give everyone another minute to make sure we can all fill out our preferences for the projects. So the Google form got a little angry. Paul, did you do the QR code here? Or did you click on the link from the chat? Or
Kyle, this is Janae. Sorry, it took us like a whole couple minutes to figure this out. We always are like, is it me? I used both the link and the QR code, and it says you need permission to use this form.
okay, that is interesting. It's supposed to be anyone on the internet with this link.
Can edit.
Yeah, it has no restrictions.
And while we are waiting on that, I just want to also point to Delilah message while we're working on this. So, you know, keep in mind, we're giving your introduction to AVELA and these amazing students' background and expertise, so that we can come up with a cool project that resonates with you. So just keep that in mind. So please, but Kyle, while you're fixing that, we will come back to this revisit. Thank you.
Okay, they're saying that this link that I just sent worked. Cool. So everyone just use the most recent link. I'm pretty positive it's the same link that Kiana sent, but you know what? We'll just roll with this. And so to fill it out, I know someone else had asked that question. Yeah, it's just ranking. If you preview it. Only letting folks edit. How about to keep it simple and just for the sake of time, how about everyone just send in the chat so that we can just see it, like maybe your top 3 projects, and then we'll keep going from there. Yeah, because I'm seeing a lot of folks editing it. Y'all have very interesting ideas on how the form should look.
We also should have everyone's email. And so we can also say, also for those members who couldn't be here tonight. So Kyle, I can allow you to see the emails and we can rank from top to bottom, correct? Or most interested?
Most to least interested.
Excellent.
Arduino for the win. Yeah, so you can text in your preferences in the chat and we'll be keeping up with those. And then we'll also send it out for those who couldn't show up. And then we did have a Kahoot that I'm going to look to the community college leaders to see if we have time for. Also, I'm seeing your hand, Devin. Or Devon. Did you have a hand up, Devon?
Yeah. Well, my question was about the survey. The survey doesn't allow me. It doesn't allow me to access. It says I need permission.
Yeah, I think we had goofed with that. So what we'll do is you can just text your preference from those projects into the chat, like kind of you can see some people are doing. And then we'll also be sending the survey out after, and we'll be kind of looking at both of those to make sure everyone's getting their opinions in. Yeah, and 1 equals most interested.
All right, I put what's most interested to least interested in the chat.
Cool. Thanks, Matt.
And real quick, Kyle, I think if we are able to do this Kahoot relatively quickly, we should be able to still do it. So yeah, let's jump on it.
Okay, cool. I promise this QR code works. So if everyone scans this QR code or just type kahoot.it into the chat, into your browser, then it should take you to a Kahoot page that asks for a code, and I'll get to you to the code in a second. I just want to make sure everyone has the opportunity to click on this first. And then Devon, did you have another question, or forget to put your hand down?
Yeah, my hand is still up for some reason.
Okay, all good. Yeah, so if everyone can log on or get to the Kahoot.it, Janae sent it to the chat, then what I will do is give y'all the code so that we can start logging in. Gonna do classic mode. And here's our game pin. Oh, it also has a QR code right there. I didn't realize. That's a new feature.
Okay, this is my new favorite way to spend 5 o'clock. I'm already having fun just putting a nickname. I need to get out more.
Yeah, the community college leaders can feel free to join too.
Oh, I did.
Okay, wait, time out. Who Kyle J? Still got a couple folks rallying.
And if there's participants who do have a time, need to go off, we appreciate your time. We'll be sending an email and sharing all the emails from our participants. So thank you for your time. We'd love to see you play, but we understand.
Yeah, sorry for going late. Thanks Ian for coming. And anyone else who's got a dip. Cool. I think I'll get started with the 20 we got here. 19 we've got here. $20 we got here. Okay, I'm gonna rock with that. Okay, let's get it going. What does the T in STEM stand for? There we go. Technology, science, technology, engineering, and math. Shout out to the leaderboard. Let's see. True or false, AVELA is an acronym for A Vision for Elephant Lion Astronauts. Someone thinks that AVELA has a much more fun name than it does. So A Vision for Electronic Literacy and Access is what AVELA stands for. It looks like one of the old leaders thought it stood for the Lion Astronauts. So then this one is, which of these is not a UW engineering area of impact? There you go, interactive and social media. Definitely didn't make the cut don't see that being related to STEM. Aerospace, robotics, yeah, those are part of the core. Let's see. Leaderboard change. Ooh, big switch up. Which of these companies does not need a computer scientist? Three, two, one. There you go. I had a feeling some folks would say Wendy's. They've got data that they need to manage just like any other company. So yeah, every company is going to end up needing a computer scientist to manage some part of their business model. Looks like I'm making my way to the top. Kyle J, shout out. Which of these skills is very important for STEM majors to have? There it is for the folks who read carefully. So all of these are extremely important for STEM majors to have. However, the answer that said pay close attention to the details had a little hint that it was the correct answer for this test. So a little bit of a trick question. Sorry I had to do it to y'all, but you know, it switched up the leaderboard. Kobe on fire. Next question, which image is different? Gave y'all a little extra time on this one. Devon, you got a question?
Yeah, my screen is frozen and won't let me see questions.
You could try pulling up on another device, maybe?
Possibly, yeah, I could try that.
All right, Oscar, I don't want to see any more misclicks. Catch up on that leaderboard. He said the answer easy to find.
Oh, am I playing? No, right? How?
So there's a difference in the blue one here with the little gray addition. It also makes the extra fin look a little shorter. Let's see here. Are the people saying it's easy? I'm not seeing in the top one spot though. So let's see it. Which was the first university to offer an engineering degree? Well, history lesson. There it is. That looks like most people just guessed, but it was Norwich University. Liban, you remember where this university is at? Which state?
Yeah, it's in Vermont.
There it is. Let's see. There it is, Bill. Bill on fire. 7 in a row. What does DNA stand for? Y'all might have a guess on who wrote this question. Shout out to her. There it is. Lots of STEM folks in the crowd. And the first one does sound like it would be right, the red one there, but a matter of fact, it is. Kiana, how do you even say this?
Deoxyribonucleic acid.
There it is. Thank you. Bill's still on fire. Well-rounded student right there. So what happens during pneumonia? Yep, the air sacs fill with fluids or pus, something that's commonly happening with people who have COVID. Bill still on fire. He might close this one out. We got one last question for y'all. Can someone knock Bill off? Which is the correct formula that relates voltage, current, and resistance? Y'all better hope Bill ain't get this one. He knows about science. He knows about computer science, biology. Yep, current equals voltage or resistance, or more commonly, voltage equals current times resistance. So let's see the podium here. Kobe, shout out to third. Connor R, shout out to number 2. And I think we know who this is. Bill R. Bill, the science guy. There it is. And then runner up are me and whoever else that name was. I didn't have enough time to read it. So whoever Bill is, if you send me your email or if you send your community college your email, just make sure that I get your email or someone gets your email so that I can get the card sent over to you. There it is. All right, you already sent it to me. Thanks, Bill. If y'all want some statistics, these are the statistics. But other than that, that's all we got for y'all. So thanks for showing up. Thanks to MESA for hosting this great event.
Thank you. I would like to also thank Janae, Delilah, all of the MCCP directors, your amazing group, AVELA, Kyle and your team. This has been amazing. I also thank all of the students for showing up. So sorry, Delilah, I just had to say